In this example problem, I have an equilateral triangle. I have an inscribed circle in that has a radius of 3, and I'd like to calculate the area of this triangle. This actually works out pretty nicely. What you can do here is, you want to be strategic about where you draw your radius. I can draw my radius to the point of tangency between the circle and the triangle, and what that's going to do is create a perpendicular. It's also going to be a bisector. I get two congruent sides there. And I can draw a second segment across there, and what you're going to see here is that I get a little 30, 60, 90 triangle. That's a 30-degree angle. The radius here is 3, so I can double it, find that longer side along there is 6, and of course multiply by radical 3. This side is going to be 3 radical 3, meaning the whole side length is going to be 6 radical 3. And it's very quick and very easy then to find the area of this equilateral triangle, because now I know this equilateral triangle has side lengths all of 6 radical 3, and I know that the area of a triangle is equal to half the base times the height. So now I can put all this together. This is 6 radical 3, this is 3 radical 3. Multiply by radical 3 to find the height. Okay, 3 radical 3 times radical 3, that's radical 9, which is 3. 3 times 3 is 9, and the height is going to be 9. So it's half the base. Okay, base is, of course, 6 radical 3 times the height, which is 9. Half of 6 radical 3 is 3 radical 3. 3 radical 3 times 9 is 27 radical 3 square units. And I've now found the area of my equilateral triangle. In this example problem, no, I'm not standing next to a giant Rollo. This is what is referred to as a frustum. A frustum is basically the lower part of a cone. And what I'd like to do here is find the surface area of this. I'm really just going to find the lateral surface area. You can always add on the circular base and the upper circular base and find the total surface area. So I'm going to use a couple facts here. First of all, this is part of a cone, and I like to draw what I refer to as the ghost cone, and basically fill in the rest of the cone. And what I do here then is, really I have a situation where I have some similar triangles. The surface area, the lateral surface area of a cone is equal to pi times the radius times the slant height. Okay? And I have a piece of the slant height here, but I don't have the whole slant height here. If you look at a cross-section of this thing, what you really have, if you look at a cross-section, is you have a triangle. Okay, it's been cut across here. This radius is 8. This radius here is 4. This side length is 5. And what I can do here is, basically I can call this x, and I can solve for that missing length. Now you may notice that this length is half of that length. So this would be equally divided as well. You may want to use similar triangles. You're not always going to be that lucky. So basically I have a little triangle with a hypotenuse of x when the base is equal to 4. I have a big triangle with a hypotenuse of x plus 5 when the base is equal to 8, and I can cross multiply here. I get 8x is equal to 4x plus 20. 4x is going to be equal to 20, which means that x is equal to 5, which I had already said. So there that value is. What I can actually do is I can find the surface area of the big cone, and I can subtract the surface area of the little cone on top, and that's going to leave me just with the lower part. So basically I can take the big surface area minus the little area, and that's going to leave me with the frustum. So the big surface area is going to be pi times the radius of 8 times the slant height of 10. The little area is going to be pi times the radius of 4 times the slant height of 5. And so that's going to be 80 pi minus 20 pi. And that tells you that the frustum area out here is just going to be 60 pi square units, whatever my unit measures are. You can do similar things with the volume of a frustum. You can basically find missing altitudes, and you could find the big volume minus the small upper volume, and that's going to give you the lower frustum volume. So lots of different possibilities here. All comes back to similar triangles.